aspirin, we talk about acetylsalicylic acid. Okay, that is your aspirin. It's derived from the bark of a willow tree. It's the most widely used drug in the world. So when you see patients that come, they'll put your allergy forms will fill out for medications. They'll say allergy, and that stands for acetylsalicylic acid. Okay. Hundreds of millions of dollars spent annually on this compound. It's used primarily as a pain reliever, analgesic. Okay, causes a reduction of fever, which is an antipyretic. So analgesic and an antipyretic. It's among the drugs referred to as NSAIDs. Okay, it's a non-steroidal anti-inflammatory drug, just like Motrin, ibuprofen, naproxen. Those are all NSAIDs. These drugs inhibit the inflammatory response by inhibiting an enzyme called cyclooxygenase. That's how they work. The first entry in the pathway for the synthesis of prostaglandins. So it stops the synthesis of prostaglandins. That's how it works. Let me pull I meant to pull the chat box here too, so I can see if anybody has comments in chat. There we go. All right, perfect. Okay. So prostaglandins are responsible in part for pain and for fever. Okay. So it decreases pain and decreases your fever. Aspirin and other NSAIDs reduce pain and fear by decreasing prostaglandin synthesis. They stop the formation of prostaglandins. Okay. Aspirin side effects are a problem for some people. It's acidic. Okay. It's acetylsalicylic acid. Okay. Causes a lot of upset stomachs, can cause ulcers, things of that nature. Okay. Because aspirin inhibits clotting. Okay. Its use is not recommended during pregnancy, nor should be used for individuals with ulcers because it stops blood from clotting. It thins your blood. Aspirin's a blood thinner. Okay. It does reduce clotting. Okay. In those instances, acetaminophen. Acetaminophen is Tylenol. Okay. Often prescribed with people that cannot tolerate aspirin. The use of aspirin during pregnancy, okay, is a concern, has been linked with several problems associated with pregnancy. Okay. During the first trimester, okay, the use of aspirin has been associated with an increase in the rate of miscarriage. So you want to keep your pregnant patients away from aspirin the first trimester. It increases the chance of placental abruption. It can cause a delay in labor. And if those of you that have been pregnant know, you do not want to delay labor once it starts. Okay. You want it as soon as possible. Okay. Aspirin also causes bleeding complications in the baby after birth. Because you got to remember the blood from the mother is being transmitted to the blood of the fetus. Everything's crossing the placenta into the body of the fetus. So aspirin is going to thin the blood of the mother. It's going to also thin the blood of the fetus. The search for NSAIDs that are more effective in gentle on the stomach. So we have two new anesthetics over the counter, basically. And those are ibuprofen, which is Motrin, Advil, Nuprin, all the same things, all the trade names, and naproxen. Naproxen is Anaprox, Aleve. Okay? Those are all non-steroidal anti-inflammatories, both those drugs. All right. This is ibuprofen. And you see the benzene ring. And then you have the two attachments, and here's your carboxylic acid group. Okay. That's the structure of ibuprofen. Okay, this is the structure of naproxen. Very similar. This is a double ring structure. Okay, still conjugated bonding system, just like the benzene ring here. This still has alternating double bond because there's a double bond here, here, and here. So it's a conjugated double bond system, and your carboxylic acid. Okay, and this is an ether group right here instead of just a hydrocarbon. So when there's ether group attached, it becomes naproxen. Okay. And that is aspirin, acetylsalicylic acid. Sorry. Okay. You can see your benzene ring also, which is a common feature of all the non-steroidal anti-inflammatories, and they're all carboxylic acids. Okay. And this one is acetaminophen. Again, same thing with this one, benzene ring. This has an O issue. Acetaminophen is not a carboxylic acid. Okay, this is a ketone group here, and we're learning that this group is an amide group. AMIDE. We have nitrogen bonded to a carbonyl carbon. Okay, so it's a little different structure. So it's not an acid. So it doesn't cause ulcerations in the stomach, doesn't cause the upset of the stomach like acetylsalicylic acid or naproxen or Motrin or ibuprofen. Okay, because it does not have a carboxylic acid to it. It doesn't burn the stomach. Different pheromones. Pheromones are chemicals secreted by animals that influence behavior of other members of the same species. Okay, they represent the major means of communication among some of the simpler animals. Okay, they're chemicals carried or shed by one of the members and used to alert other members of the species to either presence of a danger or alert that their presence for mating, so they can continue their species. Okay, so pheromones may be involved in sexual attraction, trail marking, aggregation or recruitment, territorial marking, or signaling an alarm. Okay, pheromones have a lot of uses they can use. Others may be involved in defense or in species socialization, like designating various classes within a species as a whole. Like ants have a queen, or not, bees have a queen bee, worker bees, drone bees, and they're done by different pheromones they release, identifies them as different classes within their species. Okay. So among other pheromones, insect pheromones have been the most widely studied because we have insect problems, farming and things like that, agriculture. If we can use pheromones to attract certain insects, we can get rid of them off the fields, okay? Off the agriculture areas. You attract them into boxes that kill them, we can wipe out the insect population before they destroy our crops. So there have been a lot of studies on pheromones on insects. Many insect pheromones are carboxylic acids or carboxylic acid derivatives. Okay. This guy here, okay, this is a European corn borer sex pheromone. Okay, this is what it looks like. This is a pheromone they secrete. And again, this is what kind of compound? This is an ether. Okay, R, COOR group. Okay, and it's 11 tetradecinyl, okay, ethanoate. Where we named the ether, we named the one attached to the carbonyl group. That's ethyl. There's 2 carbons there, and this one has 3, 5, 6, 7, 9, 7, 16, 18, and it has, looks like 20 carbons. So at the 11, there's a tetradecinyl ethanoate. There's a double bond at the number 11 carbon. That's how you would name that thing, that pheromone. This, you're talking about the different bees. There's worker bees, there's drones, there's queen bees, and they're identified by what pheromones they secrete. Okay, the queen bee, okay, has a royalty pheromone because it's the queen. Okay, and this is the one the queen bee transmits. Okay, and it's 9-keto trans-2-decanoic acid. So, in other words, remember we talked about the most oxidized functional group gets the name. So here you have a ketone, and here you have a carboxylic acid. Carboxylic acid is more oxidized because there's an extra oxygen there, right? So it's named as the carboxylic acid. So this 9-keto tells you the ketone group at the number 9 carbon. Then it says it's a trans relationship, and there's a double bond at the 2nd carbon. And decanoic acid is there's 10 carbons in the chain. Okay, so you can draw out that compound. Okay. This is a cabbage looper. Okay, and this is their sex pheromone. It attracts other members of the species, the opposite sex of the species. Okay, and again, this is going to be cis because they're on the same side of the double bond. 6,7-dodecinyl, okay, ethanoate. Again, here's your, I'm sorry, it includes this one here. That's your ether, so it's named as an ether. Okay, thioesters. Okay, we use thioester a lot when we start talking about biochemistry in the next chapter, the next one after that. Okay, we're going to use thioesters. Thio means there's a sulfur instead of an OH, it's an SH. Okay, coenzyme A, a lot of things that we use for the glycolytic cycle and things like that, we're going to use as thioesters. And thioester is the same thing we've done with ethers. Okay, remember ethers are R, COO, and instead of that being S, that would be an oxygen. That's an ether. If it's an S group, now it's a thiol group. when there's a sulfur in there. Okay. The reaction that produces thioesters are essentially in energy harvesting pathways. And when we produce ATP, we use thioethers. Okay. Activating acetyl groups for subsequent breakdown reactions that we use in glycolysis. Like we do all that in biochemistry. We started that one. The complex thiol coenzyme A, okay, is the most common acyl group activator in the cell. So the thiol group bonds to acetyl coenzyme A. All right, so this is what we talked about in this chapter. I'm going to say we'll just finish up this chapter here. Carboxylic acids, okay, take an aldehyde, oxidation of an aldehyde produces a carboxylic acid. Oxidation of a primary alcohol produces a carboxylic acid. Okay. Carboxylic acids can go esterification to form esters. They can go neutralization reactions to form the salt, the carboxylic acid salt, and they can dissociate to form the carboxylate anion. Okay. Those are all the different reactions we talked about. Okay. And there's a summary of how we named them. Okay, and what went through each one. Carboxylic acid derivatives. That's a good review of what we've done in the chapter. It tells you the different nomenclature, how we name them. Remember, we placed the E with oic acid for carboxylic acid. We drop the oic acid and put an AT ending for ethers, esters. And we talked about thioesters, how we prepare them, hydrolysis. Okay, remember we got rid of water, and hydration reactions, we add water across that bond. We talked about the acid chlorides. Okay, they're very reactive. We talked about the acid anhydrides, and how did we removed water between two carboxylic acids. And these anhydrides are how we form these high energy phosphate bonds, like an ATP, for use in the body. All right. So in summary, carboxylic acids, preparation of, we talked about how to make them. Okay, an alcohol and an aldehyde make a carboxylic acid. Dissociation, what they break down. Neutralization with a strong base. Form the salt. Esterification to form esters. Okay, esters, we talked about acid hydrolysis. Okay, we talked about saponification, how we make soap, how soap works, the different long hydrocarbon chains on it. Okay, acid chloride synthesis, how you make acid chlorides. They basically just replace the OH group on the carboxylic acid. And acid anhydrides, by removing water between two carboxylic acids, creates an acid anhydride, and what those can do. Phosphorus ester formation is what we use with ATP energy harvesting that we talked about. And this is a list of all the reactions we had. Okay, preparation of carboxylic acids from a primary alcohol. We oxidize the alcohol to an aldehyde to carboxylic acid. We can dissociate carboxylic acid to its carboxyl anion. Okay, the H plus is donated as an acid in solution. Okay, neutralization by adding a strong base. We get the carboxylic acid salt, and then the metal bonds to it. And that's it. We name that first. So sodium, then the carboxylic acid name. Okay, esterification is carboxylic acid and alcohol. We form an ester. Acid hydrolysis of an ester is the reverse of this. This one just goes backwards to reform the carboxylic acid and the alcohol. Okay. So saponification forms a carboxylic acid salt. Okay. We deal with glycerol as long chain fatty acids. The long chain fatty acids are insoluble. Okay. The carboxylic acid part, the carboxylic acids are soluble. So the soluble part of water holds onto what's called the micelle when it forms. The long chain hydrocarbons bond with oil and things like that. That's how it gets dirt and grime out of clothes, because it bonds with that, and the rest of the molecule becomes soluble and lifts it out. Acid chlorides are formed from carboxylic acids. Remember PCl3, PCl5, SOCO2. Any of those will react with carboxylic acid to form an acid chloride. And those are very reactive. We use it for substitution groups. Acid anhydrides. Anhydride literally means no water. Anhydride, without water. So we remove water between two carboxylic acids to form an acid anhydride. and the formation of phosphoester, which is our high energy phosphate bond, which we use in forming ATP, which is the energy for our bodies.